Happy weekend, grade 8. Thanks for checking in to see how the questions are done that you have for homework. The first question we've already done in class, x minus 3 equals 2, and the modeled expression is here. We're going to start with the second question, which says 2x equals 9. 2x equals 9. So if we think about what does this look like as a modeled expression, let's use our, Let's use our scale. This will be our scale of equality. So we have two x's, x's is an unknown number of, or unknown value, and over here we have 9. I'll use solid to represent positive, and I'll use empty to represent negative. So we have 1, 2, 3, 4, 5, 6, 7, 8, 9. So this is a way that we can model the idea of 2x's equals 9. So we don't know how many of those dots are in there, but we'll figure it out pretty soon. So in this particular one, we have a coefficient of 2 and the variable x, and its equivalency is 9. So what I want to do is when I have just a coefficient, I want to divide these x's here into mini scale, so to speak. And I'm going to have an x here and an x here. So I've divided everything on this side onto new, smaller scales. So because I've done that, I have to take all of this and divide them equally onto the scales as well. So we have 9 there. I'm going to put 4 on each. 4 here, 4 here. And then there's 1 left over, so I'll put a half. And I guess I'll just make it like that. It doesn't. A half, you get the idea. So 1x has a value of 4.5. That's the answer to our question. Now, without modeling that, I could do it much simpler by just saying, okay, 2x equals 9. Divide this side by 2 and divide this side by 2, which is exactly what we did over here. But we're just doing it with numbers instead of models. 2x's divided by 2 gives me 1x. 9 divided by 2 gives me 4.5. So my answer that way would also be 4.5. If we look at the second question, we have 3x minus 4 equals 11. Now this is a multi-step question. It's a two-step algebraic equation that we have to isolate for. So let's model it first. Let's see what this looks like. Well, we have 3 x's, 1, 2, 3, or 3 boxes if you will. Each of these has a value in it that's the same, but we don't know what it is. Minus 4, we'll use open circles for negative, equals 11. We have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. So there's our modeled expression, 3x minus 4 equals 11. So when we have more than one step, the first thing we always want to get rid of is the constant. So we want to get rid of that minus 4. So in order to do that, I have to understand 0 pairs. So I'm going to actually add 4 to this side, and I'm going to add 4 to this side. Now if we think about equality, if I added 4 pounds to one side of a scale and 4 pounds to the other, we really don't change its value. But in this particular case, because I added 4 to this side, I'm actually creating 4 0 pairs. So they're gone. So now I have a new scale, which I can rewrite because that's now 4 0 pairs. That's really worth nothing. So I can really not write it anymore. I just have 3 x's. And over here I have, well, I'm getting lazy. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15 of them. I'm just going to put this times 15 because I'm really too lazy to draw 15 circles. And now what we have is a new equation, which would be 3x's is equal to 15. And because I have 3 x's, we have just a coefficient left. I'm going to divide it into 3 equal scales, put an x on each of them, x, x, and x, and take my 15 and distribute them evenly onto each scale. I have 5 there, I have 5 there, and I have 5 here. So what I've actually figured out is that each x has a weight or a value of 5. And that's my answer, x equals 5. Now if I didn't want to draw it out, again, I could just go over here and work numerically with it. 3x minus 4 equals 11. What did I do first? Well, if you remember back over here, I got rid of that minus 4. How did I do it? Well, I added 4 to both sides. And that's how I express it here. I have 3x equals 15. What did I do next? Well, if I think about how I modeled it, I did it over here. I divided my 3x's into 3 scales, and I divided my 15 equally onto 3 scales. When I divided 3x's by 3, I got x. And when I divided my 15 by 3, I got 5. So your answer for the non-modeled equation is x equals 5. Same thing. And our last question was x divided by 2 minus 3 equals 0. Well, it's a little trickier one to draw the picture of, but we'll see how we do. So there's our scale. And I don't have a full x. Actually, all I have I'll do it a different way. I just have half an x. I don't have a full x. I just have half an x minus 3 equals nothing. There's nothing over on that side, which is kind of weird. So this has to have a pretty unique value. What I have to do here is I say, well, I don't want to know what half an x is, but I want to get rid of the constant first. So what I'm going to do is I'm going to add 3 to both sides. Just get rid of the constant first and add 3 to both sides. Now we know that's going to keep things equal, but I've created 3 zero pairs here. And what I end up with is half an x has a value of 3. But since I don't want to know what half a value of x is, I want to know what a full value x is, I'm just going to double it. I'm actually going to double this side, and I'm going to double the weight of this side. Just double whatever was on both sides. Now this is actually a full x. Right? I'll just shade it in to show you it's a full x, because 2 halves make a whole. And over here we have 6 of them. So my answer is x equals 6. That's the modeled way. Let's look at the numerical way. Again, we had our equation to start. The first thing I did was I got rid of my negative 3 by adding 3, so I'll do it here like this. And I have x divided by 2, equals 3. What did I do next? Well, over here, I doubled it, so I times it by 2. And I times this side by 2, or I doubled both sides. When I doubled half an x, I got a full x. And when I doubled 3, I got 6. And that's my answer, x equals 6. Hope you did well in your homework. That was 7 minutes of your weekend. That's not too long. We'll continue reviewing algebra when you come back on Monday, and hope you had a good weekend. We'll see you on Monday.